Hello everyone. Today I'll be talking about energy optimization through time zone realignment in India. And then we'll try to further explore it through our own AI model. So, the contents are what are time zones, history of Indian Standard Time, problems with IST, possible solutions, proposed AI model, working of proposed model, and conclusion. So, firstly, what are time zones? Time zones are simply divisions of the earth that keep local time aligned with the sun's position. Ideally, every 15 degrees of longitude adds or subtracts 1 hour. But India, which spans almost 30 degrees east to west, roughly a 2-hour solar difference, still uses just one standard time, Indian Standard Time, which is 5:30 UTC. So, why is a single time zone problematic? The biggest issue is that our schedules are fixed by clock time, not sunlight. In the East, people wake much earlier, but by 6 am, their day has already begun. While in the West, it's still dark. This desynchronization affects our circadian rhythm, our body's internal clock. People are People end up working or studying at suboptimal times of day. Over the long run, this means poorer sleep, fatigue, and lower daily efficiency. It's a small difference that accumulates into a national scale productivity loss. In eastern states like Assam, the sun rises almost 2 hours earlier than in Gujarat, yet both regions follow the same clock. This mismatch and in their days out of sync, this mismatch affects people's daily routines. They start and end their days out of sync with daylight. Studies have shown this leads to shorter sleep durations, and reduced efficiency in both work and academics. So, what can be the possible solutions? First is of the obvious multiple time zones. The first solution is to officially adopt two time zones, one for eastern states and another for the rest of India. It's scientifically logical but logistically complex. Managing trains, flights, and national coordination could become confusing. The second possible solution is region specific working hours, which is more practical to retain a single time zone but to allow regional flexibility in start times. Schools, offices, and factories in the east could simply begin an hour or two earlier than the rest of the country. This method respects natural daylight while maintaining administrative simplicity. But the limitations are even greater. In winter, sunrise in parts of northeast occurs even before 4:30 am. Expecting individuals to begin work at such early hours disrupts circadian rhythm and sleep quality. How much, no matter how much flexibility we try, we cannot still match the sunrise and sunset hours in the eastern sides of the country. The objective of our project was to analyze the hidden economic and environmental cost of India's single time zone and to develop an AI driven simulation model that quantifies the potential savings if India were to adopt regionally optimized time offsets. Our model combines geospatial, temporal, and behavioral data to predict hourly electricity consumption patterns under different time scenarios. Using historical load data, sunrise sunset timings, and urban demand trends, it generates dynamic simulation to estimate potential savings in both energy, kilowatt hour, and monetary terms. In essence, this model acts as digital twin for Indian cities, capable of forecasting how small shifts in time alignment could produce large-scale national impacts in productivity, energy conservation, and sustainability. The backbone of the model is a machine learning based prediction system developed in Python, integrating multiple analytical techniques. The libraries used are NumPy and Pandas for numerical and temporal data processing, Matplotlib for visualization, time series analysis, scikit-learn for learning predictive regression models, specifically random forest regressor for nonlinear relationships, GeoPy and datetime modules for geographic time-based calibration. The model architecture the model architecture of the includes the model utilizes a hybrid regression framework incorporating both time series forecasting and spatial weighing. Each city's predicted energy load, AI layer. A neural prediction submodule refines the simulation by learning seasonal and hourly variations in demand. It was trained on public domain energy datasets and iteratively fine tuned to minimize mean absolute error between observed and simulated energy usage curves. Through this hybrid design, the model does not just simulate time shifts, it learns how energy consumption behavior responds to them across geographics. As seen in the plotted output, Agartala, one of the India's easternmost urban centers, displays clear misalignment between natural daylight and social activity under the current IST. By applying a +1 hour offset IST second, that is the proposed new time zone, the model forecast a daily saving of about 8800 kilowatt hours, equivalent to 3.23 million kilowatt hours annually, or roughly 16.18 lakh in energy cost savings. When extrapolated across similar northeastern cities, this points to a national energy conservation potential of several hundred million kilowatt hours per year, all without any infrastructural investment, purely through temporal realignment. India's single time zone, in conclusion, In conclusion, India's single time zone was historically chosen for administrative convenience. However, in a country stretching across nearly 30 degrees of longitude, a one size fits all temporal framework causes substantial insufficiencies, social, physiological, and economic. Our project demonstrates that data driven intelligence can guide nuanced adaptive policymaking. Instead of rigidly dividing the country into multiple time zones or enforcing impractical work hour shifts, an AI augmented approach allows policymakers to simulate outcomes, quantify savings, and design region specific strategies rooted in evidence, not estimation. In essence, this project bridges data science and policy, offering a model that not only measures the hidden cost of time but redefines how India could reclaim it. That's all from my side. Thank you.